All right, good morning, folks. So today we're going to talk about control flow. Essentially, just if-else statements, and then the stuff that goes along with them. There's multiple different types of control flow. We'll get to those things later on as we sort of go through the semester, the next few weeks, that sort of stuff. PA1 is due this week on Thursday. On Thursday as well, I will assign PA2. So we'll sort of keep going with the regular PA stuff. Make sure that you've pushed everything up for PA1 so that it's on your GitHub repo website. If it is, then I can view it. So as long as you see it there, then I can see it there as well. For PA2, I've integrated the unit tests into GitHub Classroom as well. So the tests that you run in Eclipse, they will actually be run directly on GitHub Classroom when you push your project up. So it will, I think if they fail, it sends you an email. If they pass, I don't think it does. So that's just another place where you can sort of make sure that it looks like that they've passed. But if you see it passing on your Eclipse, then it should pass just fine on the GitHub Classroom because it basically runs the same thing. Okay, so to start off today, I just want to mention that there's a few exercises that are sort of throughout the lecture. I'll flip over to Eclipse and I'll sort of go through those and give you my take on sort of how to approach them and potentially little sort of tips here and there when you're trying to solve some of these problems. So control flow essentially refers to the order in which your program statements are executed. So that code that you write, how is it going to be executed? What order is it going to be executed in? The code that we've written so far in class and for PA0, PA1, it's just executed straight through. We start at essentially the top, the line after main, and we execute each line one at a time, one right after another. There's no line that doesn't get executed. We don't skip over anything or anything like that. So control flow gives you a more complex capability to control what exactly gets executed depending on the situation. So maybe at some point you need to choose between one of two possibilities or one of three possibilities to execute. Maybe someone types in a number and you want to tell them, is the number odd or even? We'll actually do that example here in just a little bit. So you want to have some code if the number is odd, and you want to have some code if the number is even. But you don't want to run all of the code. You just want to run one or the other, depending on the situation. So this is one of the things that control flow refers to. So the basic steps, let's say you were going to give a greeting to someone. The way you greet someone depends on who they are. There's a condition there, that sort of you would have to interpret. So for example, if you're looking at a friend, maybe your greeting would be like, yo, or something. If you're looking at an enemy, maybe you wouldn't say anything. Maybe there'd be sort of a glare or something like that. The key that I want to sort of point out just in this little dumb example is the if. If you're looking at a friend, if you're looking at an enemy, because that's going to translate into some code in just a moment. So Java uses if-else statements to choose between different alternatives, different things that you might want to do. So as the example, if I took that dumb example I just gave, and I turn it into code, I would have something that looks like this. So you would see this if some condition, then you would print out yo. Otherwise, you would print out glare. In the slides that I show, oftentimes I will give you sort of a concrete example, and then I'll show you a general form. Of a more generic case. So the generic case for this is just if some Boolean expression. We haven't sort of used Booleans that much, but a Boolean is just a true or a false. So a Boolean expression is something that is true or false. So if something that's true or false, if that's yes, then you run the code here. If it's no, then you run the code here. Now look at some of the syntax here. We've got if, we've got parentheses, and then we have more of these curly brackets. And we've seen those before. They're sort of the curly brackets. That's where we put our code inside of main, in between the curly brackets in our sort of main function. And then we have curly brackets for our public class thing. Curly brackets represent a block of code. So this block of code after the if, the open and close curly brackets, represents the code that you run if the Boolean expression is true. And then after the else, it's the code you run if the Boolean expression is false. So that's the idea of an if-else. You pick one of two possibilities, you never do both. So it allows us to skip some code depending on the situation. So that's where this control flow comes in. Some of the stuff that I sort of say while talking about the examples, I do have in words on the slide. So if you come back later to the slides or something and you want to look at them, a lot of times you will see this sort of stuff. So I'll sort of say out loud as I'm talking about it, and then you'll see it in words in the slides as well. Okay, so in other words, you do either or. That's the situation. You never end up doing both of them. Those statements in between the brackets, they're the code that you run depending on the situation, and it can be any code you want. So you can print things, you can do calculations, you can ask for more user input, you can even put more if-else statements if you want to. Any code that you want to put in there, with some exceptions, but nothing we have to worry about at the moment. Any code that you want to put in there that you've seen so far, you can do. So it's just more code that you run in a certain situation, but it would be between the brackets for the if and the else. So Boolean expressions are essentially calculations that give you either true or false, kind of like Boolean variables. Boolean variables are just true or false for themselves. And a Boolean expression is like a calculation. They typically involve comparisons. So there's a bunch of comparison operators, and you may have seen some of these before. If you've sort of done some other languages, you've probably seen some similar ones to this. These are the main ones. There are some others as well, but these are the main ones that you'll use in this class. Things like equal to. If x is equal to 10. Not equal to. So exclamation point equals or bang equals if x is not equal to 5. If hours is less than 40. If dollars is less than or equal to 100, and so on. So these are the most common ones, and they're typically what you're going to see in the Boolean expression in an if statement. Now, I'm going to mention this multiple times, and one of the things that you can sort of always tell if a professor mentions something on multiple slides or they sort of emphasize it multiple times is that it's probably worth paying attention to or worth remembering. Equal to. It has two equals. Remember that an assignment statement, we just use one equals to assign something. To ask if something is equal, so is x equal to 10, that's when you have to use 2. Now, it can be tough to remember because normally when you're typing code, oftentimes you're sort of thinking about it in terms of sentences, like I just said it, if x equals 10. So it's very easy to just put one single equals in and that'll be good. Now, Java and Eclipse will warn you. It will tell you that, hey, there's something wrong here, but not all languages will. I've had plenty of situations where in a language like C++ or something, I would put one equals in, and then it would do some weird stuff because it would still work, but there'd be some weird stuff happening. So it's always two equals. The way that sort of way back when I was in CS1 doing C++ stuff, the way that I remembered this was when I would say it out loud, or when I would sort of think about what I needed to write in an if statement like this, I would say if x is exactly equal to 10. That would give me two words. Both of them have e's. I need two equals. It's just a little thing. I don't do it all the time nowadays, but if it helps, remember that it's two equals, then that's something that is worth doing. Again, Eclipse will let you know that if you put one equals here, it's not going to work, but not all languages do that. But these are your sort of standard comparison operators that we're going to use today. So let's go in and into Eclipse and let me just show you just a sort of a simple example of this. So I'm just going to go through sort of the regular process that you would do for a homework or something, reading in some user input, doing a calculation, and doing a print, but we're going to have an if-else statement involved in this. So I just have a sort of a blank project, blank file, something that you could create, or you could grab one of the previous examples that we've done, and you can certainly follow along here. So I'm going to create a scanner first because we do want some user input. So this will be a new scanner, system.in. And you will be writing this many, many, many times. So it's definitely worth remembering. I already have the scanner imported. That's something that you may have to do if you haven't, if you didn't sort of clear out some other code. If this is a brand new project for you, you do need to import the scanner. All right, so I'm going to create a double, and I'm going to call it input value. So this will be the place where I store whatever the user enters. So let's ask the user for some input. So similar to the homework that the PA1 that's due this week. So I'll say, please enter a number. I'm not printing out any values associated with this, so I'm going to get rid of args. And then I'm going to say input value equals input dot next double. So just like for the homework, this will read in a value. Now let's check that number. Let's print something out depending on what the number is. So I'll do something like this. I'll say if input value, if that is, say, greater than 100, then let's print something out. We'll say the number is greater than 100. And I'll put a new line, and I'm not printing out any particular value. I don't have any like %Ds or %Fs, so I'll get rid of args. And then I'll put in an else. So just like with that generic form on the slides show, I put if, a Boolean expression, and I throw in some brackets. And then I do an else and some brackets. And then I put whatever in here I want if the if condition is false. So system out, printf, and I say the number is less than 100. Now, we're going to talk about sort of inclusive versus exclusive in just a second. So I'm going to change what this says when I run it. But for now, we're going to leave it like this. And then after my if-else, so after this little sort of if-else block of code, I'm going to print something else out that says, thank you, and a new line. So it's a relatively sort of easy printing stuff out. We're not really doing any major calculations, except we're just checking, is the input value greater than 100? So when I run this, please enter a number. Say I enter 99. Since the number is less than 100, thank you. It will always print thank you. The only decision that it has to make is which one of these to print. Do I print the one that says greater than or less than 100? So if I run again and I put, say, 200, then it says the number is greater than 100. Now, you might look at this and say, well, what happens if you type in 100 exactly? Because in here, I don't say anything about equal to 100. So let's see which one actually prints out. If I type in 100, it's going to print out the one in the else. It says number is less than 100. So my print here isn't exactly correct. The input value is checking here if it's strictly greater than 100. So 101 will print this out. In fact, I allow myself to print out a double. So if I put 100.1, it's still going to say greater than 100, which is true. So this is checking for strictly greater than, which means that equal to 100 is in the else. And these things can be a little bit tricky to determine, especially if you have sort of a complex expression here, which one's actually going to print. So it's always worth sort of testing out some of these specific cases. In this case, it was 100. Check and see which one 100 goes into. So here I should say the number is less than or equal to 100. That's what I should say because of that edge case. If you hear somebody talk about an edge case, this is the kind of thing that they're meaning. Something where it's that sort of tipping point between what's in the if and what's in the else section. So the idea with the if-else, you only print one of the things. You can do whatever kind of check you want to do as long as it's some sort of comparison. So the equal to, the not equal to, less than, greater than, or the less than or equal to, or greater than or equal to. Those are the typical checking conditions that you're going to do. So as far as this code goes, and this example, does anyone have any questions? So if we head back to the slides, that example is here, the one that I just worked out, and then I have sort of in words here sort of what's going on. If the if condition is true, the statement between those next curly brackets is run. It skips the else and then continues on after the else. That's why we get the thank you printed both times, no matter what value we type in. If the if condition is false, it skips the curly brackets, it goes to the else curly brackets and runs that. So that's sort of in words what's happening in that piece of code. So here's just another example. I didn't put the user input stuff in here just to save space, so I didn't completely go out of the range of the slide here. But you can imagine we got some user input, create the scanner, do the printing and whatever stuff we need to do. So you can imagine we just sort of pretend we have user input. And let's say the user entered a value of 15. So we just check. 15, is that greater than 0? Yes. So the number's positive. Otherwise, the number's negative, and we have the thank you. So it's the same sort of example we just did, just I got a couple of extra pop-ups here and sort of going through that process from the previous slide, that sort of wordy process. So this is relatively simple. We're going to do one more sort of example, and then we'll look at some more complicated versions of this. In PA2, you're going to have lots of if-else or if-else, if-else. We'll get to that in just a second. So you're going to have lots of those coming up in your homework that's going to be assigned on Thursday. So let's do another quick one. We're going to write a program that reads an integer, so it has to be an integer, and we're going to determine whether that integer is even or odd. So this needs a little bit more calculation. Remember that even numbers are divisible by 2. Odd numbers are not divisible by 2. So we have a little bit of information, sort of from our sort of algebra, sort of math knowledge. And we need to figure out what to print to the user. So the style will be the same as the two examples you just saw. The calculation part is what's different. So if we go back here to some of our code, I'm just going to delete all of this except for the scanner part, the creation of the scanner. And instead of creating the variables right away, because let's say I don't know exactly what variables I need, we'll sort of create them on the fly. So you sort of see a different way of creating your variables. So let's do a print first. And let's just say enter integer. And close it. We're not printing out any sort of values, so we can get rid of the args. So enter integer. So let's create an integer to store whatever the user enters. So int, call it value. This is going to be the assignment and the declaration all in one line. So I've declared value, and I'm going to assign it input dot next int. So the user types in the value, and it gets stored into my newly created variable value. Now this isn't quite it, because if we had an if block, so let me just outline the if block first. So this is what my if block is going to look like. I need to put an expression here. But how can I tell from this, just using sort of one thing that we did before, like an equal to, or a less than, or a not equal to, based on what you've seen so far and the Boolean expressions that we know of, we don't really have an easy way to figure out if it's odd or even with sort of a simple situation like this. So before we check for our if. Let's do one simple calculation. I'm going to create another variable. I'm going to call this remainder. Remember what operator gives us the remainder. You had to use it, or you could use it in PA1 to help you with PA1B. The remainder is the modulus. That's the percent. That tells us how much is left over after a specific division. So if I take any number and I divide it by 2, the number is even if the remainder is 0. So if I do value mod 2, this gives the remainder of value divided by 2. So if this value is 0, then the number is even. If it's not 0, then it's odd. So I have a situation here where I can say if remainder is exactly equal to 0, then I can say the number is even. Otherwise, so in other words, if it's not equal to 0, then the number is odd. So to get it into a form to actually do the if statement in sort of a concise way, the ways that we've seen in the past few slides, I needed to do another quick calculation. Read in a value, compute its remainder if divided by 2, and then use that remainder to tell me what to print. So if I come in here, I do have to read in an integer. I'll show you what happens if I read in a double as well. So I put in 5, the number is odd. I put in 16, the number is even, and this will work for any of the possible situations. If I make a mistake and I put in like 1.2, then it will give me an issue. So you get a bunch of red text. Don't be afraid of the red text. It tells you a bunch of information about what's going on. So here at the very bottom, typically, it'll tell you where the error was. So if I click on the main.java:9, it tells me it happened on line 9 right here. And the actual error itself was a input mismatch exception. So I tried to type in a double when I was expecting an int in my code. So if you see something like that, don't be afraid of red text, the program crashed, what do I do? It's trying to tell you as much as it can about what actually happened. So that is something to keep in mind. Okay, so when it comes to the if-else, does this make sense? Does anyone have any questions? Because we're going to go a little bit more complicated here in just a few slides. Right. So that the sort of potential sort of answer, the potential solution is here. It's basically what I wrote out. Equality for strings. So sort of arrays of characters, strings of characters. It's a little bit different. Strings are actually objects, which means they actually follow some different rules than sort of regular numbers. If you want to compare two strings, you have to use this string equals method. So you have to do something like this. Whatever your string is called, the variable name, dot equals, and then you can put something else in parentheses after the equals. Don't worry, we're going to look at this. I'm going to write up a quick example of this. This is something that's very easy to forget, that you have to use this sort of equals thing when it comes to strings of characters, but it is very important. All of these can be variables, so if you have two variables, string 1 and string 2, you can compare just like this, string 1, dot equals, and then string 2. So this is sort of your standard way to compare strings. You have to do this, and in the little example that I'm going to do right now, I'll show you what happens if you don't, if you just use an equals in there. So back to here, we get rid of this piece. So the code that we just wrote, and we'll do a quick string version of this. So I'll do another printf. I'm going to say something like, I don't know, enter a name. We're going to create, and this time we're going to store the value into a string. Our string starts with capital S, and maybe I'll just call this user. And that's going to equal input.next. We haven't seen next before. We've dealt with next int and next double. If you want to read in a string, so if you want somebody to be able to type in just characters, then you would use next. Now we'll check. So let's just outline a if-else. So here's my if-else. I need to fill in the condition, and then I can fill in the code. Oftentimes, if it's sort of a relatively standard structure, you'll see me do this kind of outline. So I'll do the sort of outline of the if-else first, and then I'll just fill in where I need to fill it. So let's do this in a very naive way first, and I'll show you how it doesn't work. So let's say I want to check, does the user, the thing that the runner of the program entered in, if I did this, user exactly equal to, say, my name, Micah, then maybe I'd write something in here, say printf, hello, like this. And I can just get rid of the args here. And then same thing in the else, except I will print out maybe like invalid user. Something like that. Initially looking at the code for sort of initial inspection, you might think, okay, this looks like it'll work. If the user is equal to Micah, then I'll print that out. Otherwise, it's not going to. So, and even if you do some tests, so if I just put in some random stuff, it's going to say invalid user. Okay. But if I type in the correct thing, including the correct capitalization and everything, it still tells me invalid user. Now, there's nothing wrong with the code that I wrote except this. I have to use the dot equals. So I can say user dot equals, and then I'll put parentheses around what I'm checking. So in this case, I'm checking Micah. Now if I type in the correct value, now it works properly. So if you do use an equals equals, it will treat it as false. There are certain situations where it would treat it as true, and we'll probably talk more about those in the future. But for now, if you use equals equals, no matter what the two values are, you will get a false. So make sure you use the dot equals. And these are those little things in most languages. Most languages have something like this, where it's this little thing that you can use it in this situation, but not in this situation. I like to think of it as learning a language. If anyone in here knows multiple languages, you've seen all of this kind of stuff before. These little sort of nuances about how to pronounce certain things or how to spell certain things. We see it in English all the time, that there's sort of general rules, and then there's stuff that breaks those general rules. So Java and lots of other languages are essentially no different. We have some rules that work most of the time, but not all the time. You might have to do something a little bit different. So when it comes to strings, there is that sort of little different thing. In the future, in a class like CS2, if you're continuing on with the sort of CS sequence, we will actually write our own versions of equals. So equals isn't some sort of magic thing that Java has. It's just some code somewhere, and we can actually write our own versions of it, which is kind of cool as well. Okay, so strings, a little bit different. And here's that example of this using the dot equals. All right, so I've showed you the sort of general syntax, but you can actually omit the curly braces if you want to. I don't recommend doing that when you're first sort of learning how to do all of this coding stuff. But those curly brackets that we have right here for our if-else, the ones that sort of create the if block and create the else block, you can omit those in certain situations. So if you only have one line of code, like in this case here, I've got one line of code for the if, one line of code for the else. This will still work properly. So if I run it and I type in something, it'll still work. That's the only time you can do this. If you have one line for the if or one line for the else, you can get rid of the curly brackets for that particular case. So sometimes you will see code that just doesn't have these in here, doesn't have the curly brackets. It saves a little bit on space. That's sort of a justification for it. But when you're just learning, so for example, something like this. So when you're just learning, I just recommend always using the braces. Typically, it gives you a little bit more white space, so it makes it a little bit easier to read, and there's sort of less chance for errors. So I would recommend keep putting in the curly brackets. This is also true in most languages. You can sort of get away with this in certainly most C-like languages. So it's not just a Java thing. But unless you're sort of used to that sort of syntax, or you sort of know what's going on, you've used it a bunch before in other languages or something, I would recommend keeping the brackets in there. In the code that I write in class, I'll typically include them even if there's only one line, just to be more explicit about what's going on. Okay, so what if you want more than two options? So this is where stuff starts to get a little bit more complicated. What if instead of just having one or the other, maybe there's 3 or 4 or 5 or as many options as many options as you can possibly handle. So the standard if-else that we just saw gives you 2 choices. But this is where an else-if comes in. You can add as many else-if statements between the first if and the last else as you want. So you can have as many possible conditions as you want to. The key is that they're tested in order. So as soon as it finds one being true, so the first condition it finds that's true, it uses that one, and then it skips everything else below. If it doesn't find any that are true, it will run the final else if it's there. And you can actually leave off the else. So it's all these little caveats. So as an example, going back to this code here, I can remove the else. I don't have to have the else there. There's nothing saying that the else has to be there. So if I type in something that's not valid, it just doesn't do anything afterwards. The program ends. So you don't have to have the else. And you can put else ifs between. So as a generic form, something like this. If some expression, if that expression is true, run this one. And then you would skip everything else. Else if this expression, if this one's true, then you run this code. Otherwise, you would run the else. You can put as many of these else ifs in there as you want, and you don't have to include the else if you don't want to. So there's lots of sort of little things associated with this, about what you can include and how many of them, and things that you can omit, stuff like that. But we're going to look at some of this else if. The key to these sorts of expressions are that the first one that it finds that's true, that's the one it does. Even if ones below it might be true as well. You could potentially have a situation where multiple of the if and else ifs are true, but it's only the first one starting at the top. So the first one that's true, that's the one that runs. None of the other ones will. So let's look at a couple of examples of this, and then we'll do a quick exercise. So here is a if, else, if, else. So say if x is greater than 10, then we're going to print that x is greater than 10. Else if x is less than 5, then we're going to print less than 5. Otherwise, we say x is between 5 and 10. So we have sort of 3 conditions. Greater than 10, less than 5, everything else. Now, one of the things to think about here, something that I mentioned at the very beginning, is sort of inclusive-exclusive situation. The first if does not include 10, greater than 10, strictly greater than 10. The else if does not include 5, strictly less than 5. So if you think about what does it include and what does it exclude, the first 2, this one excludes 10, this one excludes 5. Between 5 and 10, that one is inclusive of both 5 and 10. So it's worth thinking about this when you see these sort of more complex if statements. What do they include? What do they not include? And this is where those edge cases start to pop up. What happens if you put in 10? Which one of these is it going to print? And is it what you want it to print? So when you're writing code, it's always worth thinking about those edge cases and making sure that you are actually doing what you think it's doing. The code's actually running the way you want it to around the edges, around, in this case, 5, and 10. So if we flip things around a little bit, let's flip around this 5. So x greater than 10. If x is greater than 5, otherwise x is less than or equal to 5. So again, we could think about what's inclusive, what's exclusive. Strictly greater than 10. So 10 here would not, if you put in 10, it would not print this first one. It would print the second one. If you put in 5 here, it would not print the second one. It would print the less than or equal to 5. So again, it's always worth thinking about this. Note that in this situation, if I put in anything greater than 10, the first and the second one are true. It is greater than 10 and it is greater than 5. But it's the first one that will be printed. The first one that's true is the one that's printed. You can use that to your advantage. We'll look at that in an example in just a second. And of course, we could keep adding more. Add another else if. Greater than 10, greater than 5, greater than 0. So if we assume that x is an integer, then we'd say x greater than 10, x between 6 and 10, between 1 and 5, less than 1. And again, you can think what's exclusive, what's inclusive. And oftentimes, you may have to code it up and run it and see sort of what does it mean? What if I enter in 0? Which one is going to print out? If you enter in 6, which one prints out? You enter in 5, which one prints out? So sometimes it can be a little bit complicated to figure out. This example here is relatively easy, but with more complicated expressions and more if statements that get put in, so you might have an if and you might have lots of else ifs, it becomes maybe a little bit more difficult to tell which one is going to be printed, and you might have to test it out. So when you see a complicated if statement like this, or when you're writing complicated if statements, definitely should check these sort of edge cases and determine what's going to happen when you type in 10, 5, 6, 4, see what happens around those cases. All right, so we're going to do this one real quick. I'm going to go in and sort of clear out what I have and show you a nice and sort of relatively easy way to do this one. So this is just sort of letter grade stuff. I'm sort of grading something and I type in whatever the score is. I want it to print out A, B, C, D, or F. Now the conditions here, they look complicated. If the score is greater than or equal to 90, then it would be an A. If it's greater than or equal to 80 and less than 90, then I would print out a B. So I had a quick question. So Alden, you're meaning something like here, right? So if you use greater than or equal to, yeah. So if we use greater than or equal to in one of these situations, then the value that I put, that would be now included as part of that if statement. So if I had an x greater than or equal to 0, now I could say x is between 0 and 5 because I know 0 is now included. And then in the else, that would have to be changed to say that x is less than 0. So potentially making a change in one of my conditions up here might lead to a situation where I have to change multiple prints, because it might change how something else is going to behave. So yeah, so there is situations where it's easy to make a mistake. You might accidentally put an equals in here when you didn't mean to, and that could cause problems. So that's why it can be quite important if you're writing up some if statements to check what happens if I put in 0. Should it print out this one here, or do I want it to print out the one in the else, or maybe print out nothing? You don't want to if you don't have an else. Is it okay what it does? So if you hear me talk about edge cases, and I'll certainly talk about edge cases in the future, when you hear me talk about edge cases, this is the kind of thing that I'm referring to. All right, so again, the conditions, they look a little bit more complicated, but it's actually not a whole lot different from the examples that we just saw. So coming back to here, I'm just going to get rid of stuff here. And I'll start by creating a integer that I'm just going to call grade. And we'll do a quick print to ask. So we'll say enter grade. I'm not printing out any numbers or anything, so we'll just do that. And then I'll say grade equals input dot next int. So I'm going to read in some integer grade where we're not assuming a fractional grade or something, so it'll just be some integer grade. And then we need to check what the grade is, compare it to some value to print out A, B, C, D, and F. So I might say something like, if grade, if grade is greater than or equal to 90, then I'm going to print out it's an A. So I'll say A. We'll just keep it simple. I don't need to print out any values, so I can get rid of the args piece. You can check at this point now. We have enough to check. We don't need an else. We can leave off an else if we don't want it in there. We can just have a single if like this, and it could be worth checking. If I put in 90, it prints out A. If I put in an 85, we don't have a situation for that, so it doesn't print out anything. And of course, the higher I go, if I print out something over 100, there's nothing sort of stopping it from printing out that it's an A. So right now, just this seems to work properly. But we have to pick between more situations. We've got A, B, C, D, and F. So let's put in an else, if, and another condition. Now, if we look back at the slides, greater than or equal to 80, but less than 90. So 89 should be a B. 90 should be an A. We know 90 is an A already, so that's fine. But how do I deal with two conditions? That's basically what I have. The easy way around this, and we're going to look at if there are multiple conditions in just a second, but we don't need to use multiple conditions here. The first thing that it finds that's true is what it runs. So if I put in grade is greater than or equal to 80, and I do this print, and I'm just going to copy and paste the print in, put out B, and I run it now, and I put in a 90, it still prints out A. Because I put in 90, it checks for 90, prints this one out, skips everything else. Even though this is true as well. This is greater than or equal to 80. If I type in 90, it's true, but it's not the first one it comes across. Whereas if I type in 89, this is false, so then it hits this one. That's true, so it prints out B. So we can keep going like this. Grade is greater than or equal to 70. And we can put in here for C, and then also for D and F. This for D, and we can use an else for F. So something like this will work for us. If I put in 62, that's going to show up as D. If I put in a 24, this show up as an F. So this will work properly. And it was the fact that we used our knowledge about if statements that it's going to run the first one it comes across. The first one that's true. So we could make it very simple on our conditions. Greater than or equal to 90, 80, 70, 60, else. So that's the idea here. That's the idea of these sort of multiple sort of if, else, else. This is about as complicated as it gets, except for the condition. We can have more complicated conditions that we're going to look at here in just a second. So questions, other questions so far?
Quick question. If you were to take out int and put double and put next double, would you be able to put decimals in at that point?
Yeah, so if I were to make both of these doubles, so I made my grade a double, and I make this next double. So here, yeah, so if I put in something like 90.5, it would show up as an A because it still does the check. It by having a double here and an int here, it will consider this to be essentially 90.0 in terms of a double when it does the check. So I could do something like 89.999 and so on, and it would give me the B here. So it is checking sort of exactly as if these were 90.0, 80.0, and so on. Yep.
Okay, thank you.
Yep. Okay, so all right, so that sort of solution here for this is here, a potential answer for that. So it's essentially the similar thing to what I just wrote. Now, Boolean expressions can get more complicated. So again, we're going to sort of take this sort of simple Boolean expression, if x equals something, and we're going to extend it a little bit. So multiple comparisons. Let's say you need to check two things. Is x equal to something, and is it greater than something? Sort of both at the same time. Or is x less than something, or less or greater than something, or whatever, if it's between two values. So these use the literal sort of and or operators. So the logical and operator is two ampersands like this. So you could do sort of a between thing. Say if hours is greater than 20 and hours is less than or equal to 40. So that puts us in a range that restricts what hours could be to be true. Greater than 20 and less than or equal to 40. So that would be like either full-time or sort of part-time to full-time. So 20 hours to greater than 20 hours to less than or equal to 40. This entire expression will be true if and only if both comparisons are true. So the first one must be true and the second one must be true in order for the whole thing to be true. So that's the logical and operator. The logical or operator is two pipes. So oftentimes you'll see this called pipe. They're just sort of vertical lines. This is not an L. This is not a 1. It is a vertical line. On most keyboards, that will be the on the key right above your enter key. So you have to do shift and then the key right above your enter. So you'll have to. I've dealt with keyboards where it's elsewhere, and that can actually be a real pain to deal with. I've seen it on keyboards where it's on the same level as the shift. The shift is sort of shifted over a bit, and they move the key down, and that really messes with your with your sort of muscle memory. So this would be, for example, if x is less than 17 or y is less than 22. So you might have two variables, and you're just checking if x is less than 17 or y greater or y less than 22, then it would be true. So the entire expression is true if either component is true. And it's only false when both are false. So this sort of idea, it's used in a lot of different places. You may have seen this sort of stuff in potentially in math classes before. Actually, the first time I ran across sort of a sort of logical and logical or was actually when I was undergrad in like a philosophy class. We did like a whole like logic section, and so literally sort of if and only if and logical and logical or. That was the first time I ever saw this stuff outside of a math class. So it is sort of in multiple disciplines. This idea of and operators or operators is quite common in a lot of different places. So the big thing to remember: ands, both of them have to be true, or either one of them can be true, and the whole thing is true. That's sort of the main thing to remember. So as an example of a couple of these, let's say that x is 5. Let's say we wrote a program, the user typed in 5, and we have this condition somewhere in our code. So the condition, it uses an and. That's the first thing to look at. It's an and, which means both of these must be true for the whole thing to be true. So I just start with the one on the left. X greater than or equal to 10. Is 5 greater than or equal to 10? No, that's false. So I don't even have to look at the second one. If one of these is false, the whole thing is false. So this would give you a false sort of value in terms of your if statement. So 5 not greater than or equal to 10, that's false, so the whole thing is false. If x was 48, we look at the same one, so it's the same thing again, same and. X is greater than or equal to 10, yes, that's true. X is not equal to 12, that is also true, so they are both true, which means the whole thing is true. So whenever you see these sort of complex, like combined conditions, look at what the connector is, the and or the or, and then look at each condition. If it's the and, they both have to be true to be true. If it's the or, it's one or the other has to be true. So that's what these next two are. They both use the ors, so they both use the, again, typically I call this character the pipe. That's from sort of Linux sysadmin stuff. You normally use that as you normally call that character the pipe. So it's this double pipe character, so that's the or. So we have the same condition, x greater than or equal to 10, or x not equal to 12. So we just start on the left again. X is equal to 12. Is it greater than or equal to 10? Yes, this one's true. So I really don't even have to check the next one. Because if one of them is true, the whole thing is true. So I don't really even have to check this one. Down here, if we say x is 5, the first one, x greater than or equal to 10, that's false. But x is not equal to 12. That one is true, so one of them is true, so the whole thing is true. So when you see a condition like this, just take it slow, look at the look at how it's connected, whether it's an and or an or. Start with the left one, check, is it true or false? And then keep going down the line. And you can determine immediately, without having to check more, if you know that you're using an and or an or in certain situations. We could have used this type of condition in the code that we wrote for the grades, because I could have said for the B, I could have said greater than or equal to 80 and something like this, and less than 90. So that was a possibility. We didn't need to get it to work, but that is a possibility to have these sort of combined expressions help you out. So I'm not going to code this one up. This is just sort of a time type thing. You sort of enter the hour in 24-hour notation, and then it tells you sort of what the hour is in 12-hour notation. So it sort of does a conversion for you. The thing that I want to point out here is the usage of a couple of these. So it's just enter the hour, you enter it in, and then there's the if, else ifs, and the else. For the if, it says if hours is greater than or equal to 1, and the hours are less than or equal to 11. So if it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's the possibilities here. Then it prints out that number as whatever the number is, AM. So if you entered in 10, it would say that's 10 AM. If that's not the case, if you did 13 to 23, then it subtracts 12. So if I entered in 13, then subtract 12, that's 1. That gives me 1 p.m. I print out the p.m. here. So these conditions like this give you sort of a bracketed in range. Greater than 13, greater than or equal to 13, less than or equal to 23. So that's how you get a range. You use if something is greater than a value and it's less than a value. That's how you can get a range. The rest of them here are just if hours is 12, then you say 12 p.m. If hours is 0, then you say 12 a.m. So the code here isn't much more complicated than the exercises, sort of examples that I've been showing you. It just has a couple of situations where you need a range. So 1 to 11, 13 to 23. So with some more practice with this, this should become sort of second nature. Like how do you get a range, and how do you use sort of the regular sort of else ifs for as many conditions as you need. Oftentimes, and for our sort of upcoming homeworks, you'll be sanitizing user input. So this sort of has the consequence of letting your user know that they've done something wrong. So when you get input from a user, you should check that it's reasonable. So just in the previous slide, if the user enters something that's not between 1 and essentially 23, including sort of 0, so 0 to 23, there's some input sanitization here. That's not a valid hour. You're sort of telling your user that's not going to work for this, rather than either crashing, which is a possibility, or sort of not doing anything, not sort of showing any output at all that the user's done something wrong. Because if you don't do anything, you get this sort of garbage in, garbage out idea. If someone types in something that doesn't make sense for what your code to do, then you're probably not going to get a result that doesn't do anything. Bad values into your program will probably get bad results out if you don't sort of crash in between. So ifs can be used to do that sort of sanitization. You can always check after a user types in a number, does that number make sense for whatever you're trying to do? If you have a calculation where you're dividing by a value that the user types in, then you should check, did the user type in 0 for that number? Because you shouldn't be dividing by 0. Like, that's the sort of situation that you'll probably be checking for. So we will talk more about this when we start seeing some homeworks where I ask for this, but there will be situations where I ask you to make sure the user types in good values, in which case you will use if statements to try to figure that out. If you detect that there's bad input, maybe the user typed in something that as a 0 that you're going to be dividing by, you can always use this line, system.exit, and then you put in a number here. The number here doesn't really matter. Typically, you'll just see me put in 0. Depending on the situation, it might be useful to put in different values, but you're not going to have to worry about that in this class. So you say system.exit 0, and that will stop your program right where it is. So if the user types in something bad, something that's not going to work in your code or cause your code to crash, you give them a little message, and then you exit. So you do system.exit. So I will remind you of this as we need it and as we do more example stuff. All right, so essentially one more sort of example, sort of exercise thing that's going to compare two test scores. So it's going to use this sort of combined sort of if statement to determine when to print something out. So imagine, I don't know, in this class we have 2 midterms and a final. So imagine you've sort of done the 2 midterms and you sort of type in your 2 scores into this program. So back over to the code. I'm going to delete what we have here and just keep the scanner. Okay, so let's do a print where we say enter 2 test scores. This. And we'll have to read them both in. So I'm going to need 2 variables for this. I'm just going to create them sort of right here as I assign them. So I'll say, we'll just use integers for it. I'll say int exam1, and that's going to equal input.nextInt. And I'll say int exam2 equals input.nextInt. So I got my 2 exam scores. You'll type them in one after another. Remember that if you do use input like this, so you may have your scanner sort of do one thing after another, all it waits for is white space. So I can put a number, a space, and another number, and this will read them both in. I could use a return between them. I could use a tab between them. So I'll show you that when we run the program. So now I have the 2 exam scores. So let's write the if-else. And we'll probably use, I think for this one, we'll go back to slides here in just a second. I think I'll have an else if in here as well. And we'll do this. So I'll sort of outline it first, and then we'll go back and fill it in. So the slides say, if both exam scores are greater than 90, print way to go. If either exam score is less than 70, print study more. Otherwise, print keep it up. This could be something that could show up on an exam. Sort of a wordy problem that you have to figure out how to take this sort of explanation and turn it into some code. So the 3 things to note here are what your conditions need to be. Assuming that you sort of already know how to read in the scores from the user, there's the 3 situations. If both exam scores are greater than 90. So we can start that first. So I'm going to go back to the code. If both are greater than 90. So I can say if exam 1 is, let's do greater than or equal to 90. So it sort of includes the A range. And I could say, and exam 2 is greater than or equal to 90. Then we'll do that print. Okay. Trouble with the fingers today. We'll print out way to go. And a new line. So if both are greater than or equal to 90, then we print this out. Now, one of the things that I've sort of skipped here is putting in extra parentheses. I do recommend doing it. It sort of keeps, it sort of will hopefully keep things a little bit organized for you. So something like this, but they're not a required thing. So you can sort of easily see that this is the first condition and the necessary second condition. So that's something you can do. And I do recommend using things like spaces. So even though the space that's here between these two you don't need, it can help make things a little bit easier to read. So we have our two conditions here. Exam 1 has to be greater than or equal to 90. Exam 2 has to be greater than or equal to 90. For the else if, for our second condition, say if either exam score is less than 70, print study more. So if either exam score. So if exam 1 is less than 70, or exam 2 is less than 70. And again, I can add some more, a little bit more white space in here and put in the parentheses to make this a little bit more obvious. So that's something that, depending on sort of how familiar you are with this stuff, you can sort of add in to help make it a little bit more readable. So if either one of these is true, because I'm using the or, then I will actually do what's in this piece of the code. So system out printf will say study more. And the last condition, otherwise print keep it up. So otherwise, and I'll just copy this line. Keep it up. So when I run enter two test scores, I can enter something like, let's say 90 and 95. So I just put white space between them so it will read in both of these. And here it prints way to go. So it hit this first condition. If I got, for example, an 80 and an 85, then it prints keep it up. So that's where the keep it up is coming from, because it sees it, okay, haven't gotten A's on both tests. Don't have a test that's lower than 70. So that means you're sort of in that sort of B-ish range, BC-ish range. So that's why it says keep it up. So doing some of these tests around the sort of breakpoints, those sort of 90, 70, that sort of stuff, is important to know what's going to be going on. So let's say it was a 90 on the first test and a 50 on the second test, then you get the study more printed out because one of the tests was lower. So with these combined expressions here, the sort of more complicated ones, the ands and the ors, does anyone have any questions on these? And here's a sort of a potential answer to this. It's basically the same sort of thing that I wrote. Okay, common mistakes. This is the second time. We're going to have one more. We're going to have one more time of me mentioning this. When you use comparison operators, always use equals equals. If you're wanting to compare equality, always use equals equals. Never just use a single equals. Java will tell you that there's something wrong. Other languages may not. So always try to remember this equals equals. In some situations, you're not going to get any errors. There are certain situations in Java where it will not show you an error if you do a single equals. I forget exactly what those are, but I have seen it before. So just try to be careful with it. When you're reading your code, just whatever in your head, think about the exactly equal to when you're reading a Boolean condition that's using the equality like this. Also, I see this a lot on the first exam. You can't put multiple comparisons together without and or the or operators that we just saw. So this is not correct. This top one here. If x is less than, or if 10 is less than x is less than 15. This is what you would see in a math class. You cannot do this in code. You have to do each one separately. So you got to do the one for 10, and then you got to do the one for 15, and use an and between them. So if 10 is less than x and x is less than 15. So you can still translate what you would see in, say, a math textbook directly into code. You just have to make sure to include the and. It's a little bit more typing to do, but you cannot do it this first way. So on the first exam, typically there's stuff where you have to sort of take some math expressions and turn them into what they would look like in code. If you see something like this, it does have to be translated to look like this. So that's something to keep in mind, and I'll remind you guys about it before we get to the first exam as well. So the take home for today is essentially using the if-else statements when you need to choose between two or more possibilities. You got two options or more options on what code you need to run depending on user input. You're going to be using an if-else. You're going to basically be using if-else statements every time you sit down to code. Always use a Boolean expression, and you can put them in parentheses. I recommend doing that if you're not as used to them, but you certainly don't have to. Multiple logical expressions, you can put them together with the and the or operator, so the double ampersand or double pipe. You can put each of the comparisons inside of its own parentheses. Again, you can do that, or you don't necessarily have to, but if you're sort of just learning this stuff, it definitely makes it easier to read. And again, one last time, don't forget double equals for equality, not a single equals. So next time is testing and debugging. So we will do some debugging exercises. Dan will be here on Thursday, so we'll probably do some breakout session stuff. I want to go over testing and debugging relatively early because it can be very useful. And in classes in the future, especially if you are a CS major, they will help you out tremendously. There are juniors that take parallel programming that haven't done a lot of debugging stuff, and it gets a lot more difficult for them. So I highly recommend messing around with some of the debugging stuff, and I will show you how to do that next time, in addition to some other sort of testing things. PA1 is due Thursday at the end of the day. I have office hours essentially right after this class, and on Thursday after class. In addition, the CAE has their tutoring sessions on Monday nights and Thursday nights. So you'll always have a chance to see me during office hours, Tuesday, Thursday, before stuff is due, and potentially go to the CAE for their tutoring sessions on Thursday nights and potentially Monday nights as well, if you have time to do that. The information for the CAE tutoring stuff is on Blackboard. I did make a post about when it is and the Zoom link to access that. But that is all. I am going to go grab a drink, and then I'll jump into office hours. So if anyone has some hard problems with PA0 or PA1 so far, you can catch me here in 15-ish minutes or so after I grab a drink. Otherwise, I will see you guys on Thursday.
Thank you.
Yeah.
Thank you.
Thank you, Professor.
Thank you.